Good evening, and welcome to this public lecture, Sex and the City, the Emerging Role of Human Skin. Unfortunately, I must apologise first of all, I'm just getting over man flu, so if I sound a bit husky, do bear with it. My name is Matthew Patey, and I'll be acting as your chair here tonight. I am Chief Executive of the British Skin Foundation, a charity committed to raising funds for skin disease and skin cancer research. Skin. We all have it, we all need it. It's waterproof, breathable, protects us from the sun, regulates our body temperature, and gives us our sense of touch. In short, it's the most important thing we will ever wear. Although skin performs these vital roles, most of us here aren't even aware we've got it. For some, however, it's not that easy. Up to 8 million people in the UK suffer from some form of skin disease. Childhood eczema is in danger of reaching epidemic proportions, and nearly 2 million people in the UK have psoriasis. Last year, 100,000 new cases of skin cancer were reported, and unfortunately 2,500 of these proved fatal. This is where the British Skin Foundation steps in. Our fundraising activities enable world-class research to take place at centres around the UK. We're looking for treatments, preventions and eventual cures for these diseases. If you'd like to find out more about us, about skin disease, skin cancer, or would like to help us with our fundraising, simply go to britishskinfoundation.org.uk. As a charity, we rely completely on voluntary giving, so any support you're able to give is greatly appreciated. That completes my short plug for the British Skin Foundation. Now back to the business of the evening. It is now my pleasure to introduce our speaker, Professor Paul Matz. He is a research fellow with Procter & Gamble and has pioneered new methods and knowledge in their skincare business, including colour cosmetics, personal cleansing, hand and body care. He is a regular speaker at academic and industry conferences and has had several papers published in leading scientific journals. Professor Matz is a lecturer at the London College of Fashion, as well as an elective fellow of the Royal Society of Arts. In 2007, he was appointed visiting professor to the School of Pharmacy, and last year visiting professor to the London College of Fashion. May I request that any questions that you may have regarding his presentation are reserved until the end of the presentation. Ladies and gentlemen, Professor Paul Matz.
Well, good evening, ladies and gentlemen. It's absolutely fantastic to be here. And may I just say, first of all, a big thank you to the Royal Society of Chemistry for inviting me to speak tonight. And thank you to you also for dragging yourself out on a cold winter's night. I hope at the end you'll feel it's actually all been worth it. I want to talk tonight on this theme of the rather risque title of Sex in the City. I'm not quite sure how many times the word sex has been said in this room in the last few months. The emerging role of human skin. I have a lot to get through tonight, so if you don't mind, I'm going to plunge straight in. And here are, in fact, our four heroines from Sex and the City, looking rather resplendent, and obviously with a lot of skin on show. The fact is, as we'll talk about later, it is unashamedly unblemished and unwrinkled, and we'll talk more about that later. But the fact is that these ladies' skin, and my skin, and indeed your skin, and indeed the skin of the whole human race, arguably is facing its greatest challenge here in the 21st century. In fact, since the dawn of time. Whether it be in this city, or this city that we're in right now, or even this kind of city, or even this kind of city. It depends on your definition of city. I'll start somewhat philosophically and make the statement that the universe in which we live tends towards chaos and disorder. You can define it almost as a high entropy environment. And you could argue that life on Earth really is only possible through the creation of packets of order delineated by a boundary, separating the chaos of the universe from the order necessary for life within. And if we take the basic unit of life, the cell, I'm a biochemist by training, the cell really is a confined area of order within a boundary. In this case, the boundary is, of course, this thing called the membrane. What's interesting is that a single membrane is not enough for life. Cells need multiple membrane-bound organelles within them to create further areas of order to allow the stuff of life to take place. Any biochemists or biologists here, structures like mitochondria, endoplasmic reticulum, Golgi bodies, lysosomes, all the things that cells need to metabolize and to live and replicate. And the simpler the life form, the fewer the membranes. This is an anthrax bacterium, and you can see that it's actually a pretty simple beast. And compare this is a cartoon, of course, but it's a rather nice cartoon, quite colorful. But the point is that look at the exquisite plethora of membranes inside the outer membrane that allow this eukaryotic cell, the cell of the higher organism, to do what it needs to do to allow the host to live. And so, on this basis, we can construct a hierarchy of membrane structures. So first of all, we can look at the nuclear membrane that surrounds and protects, to some extent, the nuclear material in our cells. Around this, of course, we have the cell membrane, and then we have collections of cells that come together to form organs, and around these we have organ integuments or membranes, and hopefully you can see where I'm going with this. Organs come together to create a body, and surrounding all these organs, of course, we have the ultimate membrane. We have skin itself. Skin is the ultimate membrane that, my friends, you sitting here tonight, me standing at the front, allows you to live in the chaos of a universe that literally wants to claim you back to itself. From dust you've all come, from dust one day we all shall return. Here's a rather nice woodblock print from the 17th century by Adrian van der Spiegel. It shows a guy who apparently has taken a sword and cut off his entire outer integument. It's called the skin as an organ, but it might as well be called the idiot, because really what he's done is assured his certain death. Not just by things like blood loss, but actually through water loss. The same reason that burns patients often die in the first few hours, because we simply can't get enough water back into their bodies, because skin, as was pointed out at the beginning, is a barrier to water being lost from the body, as well as water coming in. But it also, he will die of opportunistic infection through bacteria, yeast, and fungi. So skin is the ultimate membrane. It's prominently visible to all, which I'll discuss in a minute, but also it's an interface. It's a barrier to the environment. It's an entropy regulator, maintaining order, the stuff of life within, and separation from a chaotic universe. So the first part of my talk, I'm going to talk about sex and the fact that skin is a signaling organ, and some of the research that we've done in this area. The second part of my talk, I want to talk about city, the fact that it's a barrier. What does it protect against? What are the challenges that are facing it in both the developed world and also the developing world? So let me talk first of all about skin as a signaling organ. I'm sure you know that the demographics of the population are changing quite dramatically in the UK and in fact all over the world. The population is aging at an unprecedented rate. Figures like this: last 25 years, the median age has increased from 35 years in 1984 to 39 years in 2009. By 2034, this will rise to 42 years. We are aging as a population. And that means that caring for aging people, caring for their aging skin, will become an issue of greater importance in the future. What's interesting in terms of the appearance of aging skin, there are two processes which come together. First of all, the aging endpoints that we recognize are first of all the expression of so-called intrinsic or chronological aging. I'm 46 years old, I've lived 46 years. But also, importantly, the superimposition of endpoints related to so-called extrinsic aging. The first, I cannot choose to do anything about it. I've lived 46 years. Time is relentless. The second, I can choose. This is all the stuff that I choose to expose myself to. As we'll see, the amount of sun exposure. If I smoke, what I take into my body. And this is a satellite photograph taken with a spectrophotometer that allows us to image ultraviolet in the sun. And this is a picture of the sun. And really, most of the things that we see are actually related to lifetime sun exposure. What am I talking about here? I'm talking about endpoints like wrinkling, This is a mechanical fault in the dermis where connective tissue like elastin and collagen loses its tensile strength, its elastic strength, and you get failure on points of flexure around the eyes and nasolabial fold. This is often termed smoker's mouth, not from the fact that people suck on a cigarette, but also from the fact that the same reactive oxygen species that are generated by UV photons in human skin are present in every puff of cigarette smoke. In fact, about 10 to the 13 ROS in every puff of cigarette smoke. Damage to melanocytes, the pigment-producing cells in human skin. And we start life with very even pigmentation. We tend to develop these conglomerations or collections of damaged melanocytes, churning out melanin all the time at an abnormal rate. Sun damage to blood vessels, much like a garden hose, loses elasticity and starts to bulge under pressure, so blood vessel walls damaged by UV photons across the years lose their elasticity and they start to bulge. I'm talking about, in this case, things that we'd call age spots, of course. In this case, spider veins, or dermatologists would call them lentigos and telangiectasia. That's just for you, Matthew. Now, here's some interesting facts. It's impossible to put figures on this, but this is in the peer-reviewed literature, and this is from a consensus statement back in 1988 from a meeting with dermatologists. It's been estimated that up to 80% of the visible signs of aging are caused by exposure to ultraviolet radiation. Isn't that amazing? So most of the things that we think of as age are actually associated with exposure to ultraviolet from the sun. What's interesting is that it appears to be cumulative, and it's not so much frying on a beach. It's more just the multiple brief exposures as a consequence of everyday life. Professor Albert Pligman, who sadly died last year, this famous quote, "The skin never forgets." And it's not so much frying on a beach in the Mediterranean. It's actually the stuff of life, going out for a sandwich at lunchtime, taking the kids to the park at the weekend. This is the cumulative exposure that we build up in our skin across a human lifetime. And so if I show you these two pictures, cropped pictures of skin, and asked you which looked the younger, I'm sure that you'd look at the top one and say, well, it looks unwrinkled, unblemished. The bottom one looks kind of coarse and pigmented. And actually, they're from the same body. This is lent to me by Professor Ronald Marks from Cardiff. This was a patient of his who lived in Cardiff all her life. She never went on a foreign holiday. She just potted around in her garden and at her allotment. But you can see that where she's been protected by her clothing across the years, there's almost perfect skin, a few inches up, around the arm, into the hand, and you have all the characteristics I just talked about. Coarser, more leathery skin, dyspigmentation, and the rest of it. And so you can see the proof in your own body. Just look at the difference between your volar forearm, the inner forearm, and the outer forearm. So the sun and cumulative exposure to ultraviolet is a huge factor, known factor, in the progressive accumulation of aging endpoints. Now, to bring this right up to date, this is from I'm going to talk about the results of research published just in the last 12 months. And this relates to the amount of particulate pollution in the atmosphere. This is a chart showing CO2 emissions from the consumption and flaring of fossil fuels. And you can't quite see the scale here, but the lighter the color, the greater the CO2 emission. And you can let your eyes pass over that, and it seems to make sense. Most of the industrialized developed nations producing the most material in the atmosphere. If you compare and contrast this with this global distribution of deaths from air pollution, and in this case it's now the lighter blue, the greater the number of deaths from air pollution, you can see there's actually fairly good correlation, which seems to make sense. But the fact is that it's not just where you live. We now have the concept of borrowed pollution. So this is, again, taken from space. Again, this is using a spectrophotometer that's able to image particulate pollution in the atmosphere. And you can see here that flaring of fossil fuels in Siberia and Russia is now drifting across the Atlantic and hitting the western seaboard of the United States. And so this as well, where Beijing actually is buried beneath this little area just here, but you can see that all of the airborne pollution is seeping into the low ground, or into the rural areas, and affecting way down here. What's the issue? Well, certainly respiratory disease is a huge issue, but actually, for the first time, we're now starting to see publications that link particulate pollution in the atmosphere to expression of aging endpoints in the skin. I haven't got time to go into this paper. It's from a good friend of mine, Professor Jan Krupman. But what he's done is taken two groups of women from the Ruhr Valley in Germany, very industrialized region, one from the country, one from city, and first of all looked at aging endpoints in their skin using a variety of different measures. He's then calculated very accurately their total lifetime exposure to particulates in the atmosphere, and found, I don't expect you to look at this, all I'm going to do is highlight the red areas here, which show that there are now significant correlations between exposure on a lifetime basis to particulate pollution in the atmosphere, and in this case, expression of pigmented spots on the forehead, on the cheeks, and wrinkles, in this case, in the nasolabial fold. Very interesting. And we're starting to see more and more papers that point to this being a factor as well. So sex and the city, city dwellers, this is an issue, but remember, borrowed pollution as well is an issue. So let me now move on to the expression of aging itself and consider how that impacts our perception of key issues like age, health, attractiveness. You met a bunch of people tonight for the first time. I'm seeing many of you here for the first time. The fact is that within 100 milliseconds, we make up our minds of age, health, attractiveness, whether you like it or not. And what's interesting is, if you think about all the things that make up the expression of aging, I'm afraid that partly my industry, but also the media is to blame for, when we use the term, I hate it by the way, anti-aging, we tend to think of as anti-wrinkle. But of course, if you took my face and you photoshopped it and took out all the wrinkles, I'd still look my age. But there's a lot more to aging. We know this, don't we, in here. And I want to start to talk about this in the next few minutes. So in terms of why skin looks like it does, and therefore how we perceive aging skin, it's important to understand how we perceive skin in the first place. So we're talking about the interaction of that little narrow waveband, of 400 to 700 nanometers, visible light with human skin, because our eyes respond to that bandwidth of radiation. So here's a cross-section of skin. I don't want to go into too much detail, just to say that this layer we'll talk about later. It's called the stratum corneum. It's about 1/1,000th of a millimeter thick. So take a piece of paper, that's 100 microns thick. So the stuff keeping you alive tonight is 1/1,000th of a millimeter thick. That's about 100 microns thick, about a piece of paper. This is 1 to 2 millimeters thick. Stratum corneum, epidermis, and dermis. Here's my photon of light. The surprising first thing is that less than 10% is reflected from the surface. The vast majority of light actually enters the skin. So when you look at me and I look at you, you're actually looking mostly within my skin. So what happens to that light? Well, it's first of all diffused. It's then forward scattered into the skin. This is highly simplified. Any physicists among you, there's a lot more scattering that goes on. But first of all, it's absorbed by the brown pigment melanin in the epidermis. It's forward scattered again. It's absorbed by the red pigment, hemoglobin, in the upper layer of the dermis. And brown and red, you mix them together as a child, and a bit of white, you've got a pretty good skin tone. A few photons of light are lost into the skin, but the molecule responsible for scattering light back towards the surface so we can see skin is actually collagen, for a variety of reasons I haven't got time to go into tonight. So light is scattered back towards the surface, the stratum corneum diffuses it, and the light-sensitive cells in our retina make sense of this, and we see a flesh tone in our visual cortex. But importantly, because we have an array of light-sensitive cells in our retina, we're able also to determine arrangements of color. And as you'll see in just a minute, it's these arrangements of color that are so important in perception of age, health, and attractiveness. Now, if you want to, we can go into the mathematics, and it all gets very complicated, but actually, human appearance can be explained very simply. It's the interaction of visible light with, first of all, surface texture. Although, bear in mind, anti-aging, anti-wrinkle. We have this fascination with wrinkles. Only 10% of light is responsible for explaining the appearance of wrinkles. It all takes place inside, where we have absorption by melanin, by hemoglobin, brown and red. And then, because collagen scatters light internally like a mirror, the brightness of the color that we see is due to the concentration and distribution and quality of collagen. And just think, we tend to lose that quality as we age, but also as we photoage, as UV breaks that material down, you start to make, it's like, oh, young skin glows, older skin tends to become more dull. Lots of interesting insights that start to come from this. Now, we can measure wrinkles very well, and any questions afterwards, I'll be glad to tell you how we measure wrinkles. Really, the last few years, we've been concentrating on developing measures of color, and specifically things called chromophores. These are molecules that absorb light. They are melanin and hemoglobin. If I can do that, I can explain somebody's appearance in terms of their color. I'm not just measuring red and brown. So here we have a method. It's a form of hyperspectral imaging, where we are able to separate out separate maps for, first of all, melanin, and then hemoglobin. So in both cases, although these are grayscale maps, the darker the pixel, the greater the concentration of melanin. So what's interesting here is that you can see across this lady's face that wherever she's been exposed to ultraviolet, she has these local agglomerations of overproduction of melanin. Same with blood vessels along the cheekbone, down the nose, the lips, it's called the vermilion zone, lots of blood. We're now trying to explain this lady's appearance. But you can also see where she's been protected from the sun by shadow underneath her anatomy, her chin, but also where she's had her hairstyle and the front of her ear here. There's zones where there's actually less heterogeneity of these features. So we can now do whole face or even whole body chromophore maps. Just to show you and make it more intuitive, if I take sections from the cheek here and I just pseudo-color them, you can see that I'm actually getting very nice exclusive mapping of both melanin and hemoglobin. This is from exactly the same area. It's the combination of these two that produce what we think of as the coloration of human skin. Just to bring this alive for you, in one of the clinical studies that we did, we were lucky enough to have a daughter, a mother, and a grandmother in the same study. So this is the daughter. If I take sections from the cheek and the forehead, and I look at just melanin, you get this. And it looks very, very homogeneous, right? I mean, there's not a lot going on. That's the whole point. We start life with very even distribution of both melanin and hemoglobin. This is the mother, the same blue eyes, by the way. And now we start to see the progressive agglomeration of these features here. And then finally, the grandmother, same blue eyes. And you can see here the final result. If we now look at the whole face, it looks a little bit freaky because anything that's not skin is not processed by the algorithm. So eyes and hair don't count. Let's just look at the skin. That's the daughter, the mother, and the grandmother. So this has nothing to do with wrinkling. This is only melanin as a chromophore. The daughter, the mother, and the grandmother. And so just subjectively, we can look at these isolated maps of melanin only, and we can start to hypothesize, could it be that beyond wrinkles, beyond the features that we classically think of as aging, could this actually be driving perception of age as well? We've answered that through, for me, has been one of the most fascinating collaborations in my career, 23 years. This is a collaboration with evolutionary psychologists, particularly Professor Carl Grammer and latterly Dr. Bernard Fink at the University of Göttingen. And if we just to consider the psychology of beauty. If you look at these images here, I'll come on to the Japanese ones in a minute. You've got Queen Nefertiti here, maybe BC 2000. Botticelli's Venus, maybe about 1550, say. You've got lovely Grace Kelly from around 1930. You look at the spacing of the features, the shape of the face, the quality of the skin. It's remarkably consistent over some 4,000 years. I did a talk in Japan recently, and I just pulled out a few figures here. And actually the same is precisely true once again here. And so, is it possible to try and define beauty in something other than a very subjective way? This is the kind of thing that evolutionary psychology, is the fastest growing branch of psychology, is trying to investigate. I think we tend to think of evolution as the adaptation of the function and structure of flesh, but don't forget also that the brain has evolved in humans to deal with the highly complex social situations that we find ourselves in. And so if we look at the results of the last 20 years of evolutionary psychology research in terms of what constitutes an attractive face, really only three things come out as large drivers. First of all, symmetry. I'm sure you're familiar with this. This made the press about 20 years ago. The fact that symmetrical faces consistently receive higher judgments of attractiveness and positive personality attributes. That's controversial, but it's peer-reviewed research. Secondly, averageness. The strange concept that the more your face conforms to a population average, the more likely it is to be deemed attractive. These are images I took a few years back, and there are 15 young ladies. If I digitally morph these together or blend them, it's not a trick, it's reality. This is the result. And I'll leave it to you to judge whether that face on the right is more attractive than any of the faces on the left-hand side. And lastly, so-called sexual dimorphic features, the stuff that makes you uniquely male or female, influenced, of course, by sex hormones, testosterone and estrogen, and these produce either masculine or robust features or feminine, gracile characteristics. Again, just for your interest, last couple of years, papers published on the way in which, again, I'm just reporting this, ladies, okay, this is not my research, but again, peer-reviewed empirical research. Apparently, during your menstrual cycle, your preference for male faces changes. And so when you're ovulating, you tend to prefer a more robust male face like this, whereas mid-cycle, you tend to go for this kind of face. This is the lover face. This is the father face. Very interesting. Now, again, we can discuss this afterwards, but this is not my research. I'm merely reporting it for your interest. So first of all, we have symmetry, averageness, and then the sex-typical features. And then the fact that somehow, across different ethnic phenotypes, there's just arrangements of features that seem to respond, that people seem to respond to wherever you are. But what's very striking is that up until about 5 years ago, there was really no research at all on skin, the covering. All the stuff I just talked about is really shape-related, symmetry, averageness, sexual dimorphic features. No work done on the substrate of skin that covers that shape itself. And so really, the last 5 years, I've had just the best time. So we've published, I think, 10 papers. We have 3 in press, and we have more on the go. And we're taking our first baby steps in just peeling back the layers, understanding what biology, in terms of skin, drives some of the judgments we make every second, of every minute, of every day, as we look at our fellow human beings. Let me just take 5 minutes to describe to you the first study that we did, and it comes directly from the insight I talked about earlier, that could it be that this progressive local agglomeration of pigment, melanin, hemoglobin, plays a key role in driving perception of age, health, attractiveness. The challenge here, obviously, is how on earth do you separate uneven color from the mess that's the human face? Bone structure, hairstyle, or lack of it in my case, placement of features. How do we do it? I'll tell you how we did it. So my job was to image 170 ladies aged between 11 and 75. And we took images from the front, the left, and the right-hand sides. We used a technique called cross-polarization to try and eliminate contrast from wrinkles in the first place. So this was picked up by the BBC a couple of years back, and it was a program in the Horizon series, and this is Professor Reagan, and it was called her beauty parlor, and the whole point was she reached 50, and she wanted to understand how she looked for her age and what products she should use. And so I was the guy at the beginning who took 10 minutes to analyze her skin, and we took her through the process. So remember, we took photographs at the beginning, front, left, and right. and then we're removing any feature in her skin that contributes to visual contrast. So we remove any lines and wrinkles. We stitch the left and right-hand sides of her face to the front to create this continuous skin map. We then want to correct for the fact that all of our different features, eyes, nose, and mouth, are in different places. And so we now have an average human face in a 2D template. All the red points, these are somatometric points which we're going to fit her features to. And we end up with this. So we've squished her face to fit. We're then going to render her skin digitally onto a virtual 3D human skull and create a 3D stimulus. And this is it. So what we started with this and ended with this. So we've applied her skin color to this standardized head with standard hair, eyebrows, eyes, nose, mouth, bone structure. And just to point out, little spot here ends up here, little scar here ends up here. And so it really is her skin applied to a standardized face. So we end up with 170 of these. And remember, the only thing that's different now is the original skin color distribution. These are just 3 picked at random. Even now, maybe you're making your mind up about these ladies' age, health, and attractiveness. We then showed these completely blind on calibrated screens to 400 members of the public in Germany and Austria. And the first question that we asked was, how old do you think this person is? And here's the main result. This is the original age of the subject along the x-axis here. This is the perceived age here. Now, first of all, yes, we have, it's called scale compression, which we expected because we're applying the features to an approximate 20-year-old head. But the real result is that we have this remarkable straight-line correlation all across the age range, which shows, basically, it proves our hypothesis that as color gets more uneven, it drives up our perception of age. So we've proved our hypothesis that independent of lines and wrinkles, uneven coloration plays a major role in perception of age. A couple more interesting facts from our further research. We've used eye tracking to look at dwell time and fixation of the human eye on faces with different levels of pigmentation, evenness. And what we've shown is that we tend to spend more time looking at faces with even coloration and less time to those with uneven coloration. You walk into a room at a party, this is what happens. Apparently, this is what happens. Now, we've shown that both wrinkling and uneven coloration drive perception of age. But there seems to be a differential weighting where wrinkling tends to code more for age, whereas color evenness tends to code more for perception of health. Isn't that fascinating? So there's a balance here that needs to be maintained as we change human facial characteristics. So as broad brushstroke statements, we can say that low contrast facial skin seems to be perceived as healthier, younger, and consequently more attractive, whatever one's age. But also we've uncovered a natural balance of visible age and health cues in human skin arising from texture and color distribution. So what happens when we give our faces arbitrarily to plastic surgeons and aesthetic surgeons, and we say, please make me look younger? If they don't understand this natural balance, then we are in trouble. And I think what we have here is maybe an explanation for some of the horrors that are leaving maybe Hollywood plastic surgeons. We have to understand how these features contribute to perception. I guarantee you, if you met these ladies in real life without any makeup on, they would look very different. This has been heavily processed. I was in a retouching studio in New York just before Christmas and was amazed at what can be done. And the retoucher understands what I've just been talking about. Now, just to finish this section off, what's interesting is that the same wavelengths that drive photoaging, that is, wrinkling, dyspigmentation, also induce skin cancer. And as we heard at the beginning, very nicely from Matthew, skin cancer is the world's most common form, and all across the world, skin cancer rates continue to rise dramatically despite public education. Last year, we published a paper that linked perception to photoaging, and we argued at the end that maybe where partially these campaigns have failed through fear of cancer, maybe, I hate to say it, maybe appealing to human vanity is also a route to getting people to apply more sunscreens and to take sun avoidance behavior. The last 20 minutes or so of my talk, I want to talk about the last part here, which is the city. I want to concentrate now on the skin as a barrier. So the skin is a wonderful signaling organ. It speaks before you open your mouth. But let's consider it now as a barrier, an interface barrier, maintaining order within and separation from a chaotic universe. What does it regulate interaction with? Well, first of all, microbes. Bacteria, fungi, yeasts, viruses, microorganisms that literally want to take your material and make it their own. Antigens, the concept of non-self. Chemical species, the surfactants and detergents, for example, that you apply to your skin every day when you wash your face or your body. Water itself, the fact that we need 70% water in our bodies to maintain life, but wouldn't it be embarrassing if you had a bath and you blew up through osmosis? So the skin has to be able to maintain water within, but also to maintain water without. Particulates, airborne pollution, pollen, dust, the stuff that we talked about earlier. Mechanical abrasion, the fact that mankind has created more artificial surfaces than ever before in the history of mankind, and of course solar ultraviolet radiation. And so this material has produced every second, every minute of every hour of every day of your life. Without it, you wouldn't last even a few hours. Skin is an interface factory, and that's the way that I view it. And this is the epidermis here, only 100 microns thick. These are epidermal stem cells at the bottom. Their whole mission in life is to reproduce themselves and to ultimately create cells that end up here in a layer called the stratum corneum. Stratum from the Latin for layer, and corneum, which means horny, because of the keratin protein that's predominant in this layer, and of course it's the predominant protein in animal horn as well. So skin is an interface factory. And how does this remarkable interface barrier work? It can be likened to a brick wall, where the bricks are the cells of the stratum corneum, called corneocytes, and there is a special mortar in between. So just to look at this in a bit more detail, this is some work that we're doing right now with the School of Pharmacy in London. This is the concept of path length, the fact that if something wants to make its way into the human body, it has to make its way around these bricks. It can't go through them. These are impervious. And simply, if I add more layers, I add more path length. And so the stratum corneum sieves the material that wants to make its way into our bodies. But I can also create path length by increasing the lateral dimensions of these corneocytes. And so here we have actually the same number of layers, but we've increased the path length simply by making the footprint of these cells bigger. And so all across the body, we're discovering this remarkable balance between the number of layers and the size of the corneocytes that dictate path length and therefore protection. What's interesting around the eye, where you have the thinnest stratum corneum on the body, is about 6 microns thick, 6/1000th of a millimeter thick. They have the largest corneocytes. So the body is trying to compensate for the fact that you have a very, very thin protective layer. Those are the bricks. Between the bricks, we have the mortar, and this is an electron micrograph of 2 corneocytes. That's the intercellular space. We have these striations here of alternating electron-dense and not-so-electron-dense areas. These are actually beautiful arrangements of sphingolipids called ceramides, and for the chemists among you, these create alternating domains of hydrophilic and hydrophobic species, through which penetrating species have to flip-flop their way through. It's all very, very clever stuff. Nature is a wondrous madam. And so we have the bricks and the mortar. So here we have a little bit of proof. This is just a cartoon. There's peer-reviewed literature that explains this as well, but this is my cartoon version. This is the thickness of stratum corneum in premature and then full-term babies. And then if you look at water loss, a measure of how good that barrier is, through that layer, you get a stoichiometric relationship. You have an almost inverse correlation where the thicker the barrier, the greater the path length, the less water loss through that layer. And conversely, you could expect it to be a better barrier to things wanting to get into the body as well. Again, this is work we're doing in the School of Pharmacy. You can use a simple equation to estimate stratum corneum path length. And sure enough, around the eye, you have the thinnest path length anywhere on the body. Forgive the next slide. All I'm doing is, oh, it's not that slide yet. So this is from Professor Michael Cork up in Sheffield. He's introduced a concept called barrier reserve. And this is the concept that it does matter how thick your barrier is, and therefore how long your path length is. So on the left-hand side, this is a nominal 18-cell layer thick stratum corneum. If I lose 2 layers from this, then it equates to about 11% loss. And if I have a very thin stratum corneum, like around the eye, if I lose 2 layers from that, just through abrasion, that's catastrophic. I've lost 1/3 of my path length. And so, again, forgive this picture. This is eczema hepaticum. This is failure of barrier function in the first place. But look what's happened. Precisely around the eyes, around the bottom of the nose here, where you have the thinnest path length, you now also have opportunistic infection by the herpes virus, where it's basically, it's the stuff of the universe. It's trying to take you and make you its own. Now, what's interesting is that all of this structure, the bricks and the mortar, if you look at its mechanical properties, somewhat surprisingly, you rub your skin and you think it's very soft. Actually, naturally, it's extremely stiff. We're doing some work with University of Stanford, and we've discovered that it has the tensile strength of steel, in fact. And so we're able to move our bodies only because we have excess surface area built into the stratum corneum. And so in the same way as we have bellows and accordion, so the skin has excess surface area that's able to extend. And so I can take this very stiff plastic in a tube, and I can make it bendy by introducing corrugations, excess surface area. Now this is a picture of my forearm, and from a distance you think it looks very smooth. It's full of texture. It's just the amplitude's very small and the frequency's very high. But it provides surface area which allows my skin to extend. But even with this, without something to plasticize it, to make it more fluid and change its rheology, it will then crack and split, much in the same way as this riverbed has split here. And what's interesting is that the only plasticizer, the only fluidizer of the stratum corneum is water. So think about the humble moisturizer, that we tend to denigrate. The humble moisturizer can add water back into your stratum corneum and make it more plastic, make it more fluid, make it less prone to cracking and splitting. Now this is it's called a water absorption curve, and what we have here is increasing water content. This is the ability of skin to take up water, and the point I'm making here, I don't want to go into too much detail, the point is skin is uniquely set up to absorb water. Polar side groups on lipid and protein that bind water preferentially. This has a profound effect on mechanical properties. Again, I don't want to go into details, just look at the shape of the curve. This is increasing water. This is a logarithmic scale. This is stiffer, this direction. This is softer, and this direction. Even small amounts of change in water content have profound effects on the stiffness or softness or plasticity of your skin. And years ago, we developed little instruments to measure this in vivo, and fascinating insights into how water alone can change skin mechanics. This is from a clinical I did maybe 10 years ago. It was a split-body clinical using a simple moisturizer containing a humectant called glycerin, 10%. This is 5 weeks application, and you can see on the left-hand side, this is her right foot, and you've got some inflammatory process, you've got some kind of redness here, you've got cracking and splitting, you've got all this corrugating skin, which is actually the skin rouging up because it's so stiff. 5 weeks of a simple moisturizer, what a difference. All of the yellow, kind of grey callus has gone. We're now seeing all of the lovely skin colour come through because we're now allowing light through the stratum corneum, being remitted back by the collagen layer beneath it, and it's soft and it's supple. Water has a profound effect on the stratum corneum. And again, this is work from the last 5 years. This is beautiful pioneering work from a group in Rotterdam. We've collaborated with them using a technique called confocal Raman microspectroscopy, a mouthful. And what we're doing is we're measuring the water gradient across this 15-micron thick layer. If that changes just a little, my friends, then we die. Isn't nature amazing? That it maintains that water gradient from about 20% at the surface, about 70%, 15 microns in. If that changes just a little bit, then we start to die. The last 5 minutes, I want to talk about the implications of skin as a barrier in the developing world. Because the fact is that skincare, for us, means softness and smoothness and better optics and all the rest of it. But the fact is that half the world, 3 billion people, living in the remote areas, and remember, most of the world still lives in rural areas, of 127 developing countries, are deprived of even the most basic skin care. And the fact is that skin disease is an overwhelming burden on first-level health facilities. It's a devastating economic consequence to low-income families. Amongst the 5 most common causes of loss of working hours and employment globally, can result in serious disability, incapacitation when diagnosis and treatment is delayed, a major loss of health and related quality of life, predominantly communicable and amenable to prevention, really quite easily, and in general, highly responsive to management. And yet, skin disease is accorded very low funding in developing countries, despite accounting for an astonishing 30% of recorded disease in urban areas and between 40 and 60% of all disease in the developing world in rural areas. Astonishing. And if we look at the kind of diseases that we're talking about, it's very interesting. If you look at the predominance in percentage terms, we have pyoderma, bacterial infection, mycosis, fungal infection, eczema, dermatitis, which is a dysfunction of the stratum corneum, parasitic infections, scabies, filariasis. I mean, the top 5 are all to do with stratum corneum failure. And opportunistic infection is, again, it's the universe getting you because you've lost your ultimate membrane, the thing that regulates order and chaos. So, once again, in the developed world, really skincare is about enhancing appearance and feel. Whereas in developing countries, if you simply maintain barrier function, you can have a profound effect on public health measures, preserving both life and health and community and family. I'm talking about things like washing and soaking with water. Importantly, water fit for drinking to reduce microbial load on the skin, particulate load on the skin, and to hydrate the stratum corneum. Emolliency, humectancy, to help retain water in the stratum corneum and to reduce friction. And then lastly, if you have compromised stratum corneum, to separate skin from the environment, some kind of covering. Washing, soaking, emolliency, covering. Very, very simple, very amenable to low technology answers. Really, the last year and a half, without sounding too, I don't even know what word to use. I feel like I've discovered a small part of why I'm here on Earth. Stratum corneum biology has fascinated me for 23 years, and yet the insight that basic maintenance of its function can save lives has captured me. Last year I went to Tanzania with Professor Terence Ryan, Dr. Claire Fuller. These are real pioneers in community medicine across the world. And we ended up in Tanzania and then this area here called Sodo in Ethiopia. I want to spend the last minutes of this talk talking about a disease called podoconiosis. Has anybody heard of this? I'd be amazed if you had. Podo, from the Greek meaning foot, and conio from the Greek meaning dust. And this is a picture, all the pictures I took in December when I went on my visit there. This is the characteristic clay-rich, red volcanic soil of the region. It's been freshly dug, and you can see it's bright red. It's very, very characteristic. It's also very, very high in silicate content. And all of the workers there are barefoot from an early age. You can see there's barefoot just there. And what appears to happen is that, again, through lack of basic maintenance of the stratum corneum, you get this gross cracking and splitting. And all of these things here, they all go down all the way through the stratum corneum, into the epidermis, often into the dermis. And these are entry points for microbes, for particles, but also for these silica moieties. I just put this in because I'm fascinated by the similarity between this and this. I think there's similar mechanics. I think there's some research there. But back to the original thing. And so, again, forgive the next few pictures, but I just want to alert you to the plight of these people in Sodo, in Ethiopia, just because their stratum corneum is broken down. So what appears to happen is that silicate particles enter the skin, they're taken up by the superficial lymphatic system, but you then get obliteration of the lymphatic system, and what then happens is that you get a cycle of events. First of all, you get these papillomatous projections forming. The disease is called locally, it's called mossy foot, because these projections look like moss. And then you get hard nodules forming, and this is a connective tissue problem. And then with the failure of lymphatics, you get, it's called lymphedema. And these are two useless limbs. And this is the clinic where these people arrive. And you can see, first of all, the variety of disability that they have, but also look at their faces. Look at their body positions. They are rejected by society. They smell bad because of infection of their skin. Nobody wants them. They're embarrassed, and they stay indoors. Look at them. And it has devastating consequences. They can't work. They can't earn a living. They can't attend school. They can't marry. It gets me every time. They're shunned. They're lonely. They're treated as lepers. They are in constant pain. Ulcers, cracking the skin, itching, infection. Often they starve because only the lucky will receive family support, and often they'll have early death because of infection or starvation. And by the way, there's 2.9 million people in Ethiopia with this. Incredible. Ethiopia alone. But here's the hope. First of all, in terms of prevention, and then in terms of treatment, simple intervention, washing with water, application of simple emollients, local plant oils, and mobility are extremely effective in terms of prevention and primary mode of treatment. The problem is that large quantities of clean water are hard to come by in the developing world. This is the reality of rural Africa, where most people live in these conditions. This is the reality of people getting water, places like this, or rivers, or streams, or springs. Look at this lady here. She's washing her feet. The other end, they're collecting water for drinking to take back to their homes. This is a 10-year-old girl. I have a 10-year-old girl. She brings back water for her family. This is the ubiquitous yellow plastic 20-litre container. 20 litres weighs 20 kilograms. And so here she is taking back water on her little wooden carriage. Here's a lady with ropes cutting into her shoulders, 20 kilograms hanging off her back. She's just walked 5 kilometers from the local water source back to her hut. This lady here, she's in her 60s. She has podoconiosis. She can't walk anywhere. Her family have left her, and she's left to fend for herself. And in terms of the priority of water usage, why would you wash skin with it? I mean, really. And so in Tanzania last year, I did a survey. And in general, this is the order of priority. If you have water, you drink it. Then you cook with it. If there's any left, well, you may wash with it. In the Maasai, you give it to your cattle, then you drink it, then you use it for cooking, then use it for washing. Here we have Anna and Abel. I interviewed her, and she looks well-groomed, but the fact is that her son has cerebral palsy. Every morning she gets up and she walks 2 kilometers to fetch 20 liters of water. She carries it back on her head. To boil the water for drinking, she's one of the ones recognized that she has to boil the water, otherwise it contains pathogens. She then scavenges firewood. She repeats the whole thing in the evening, and unsurprisingly, unboiled water is used only sparingly for skin washing. But there's other problems as well. You can have water on your doorstep. This is the village of Shirimungani, 6 kilometers from Moshi in Tanzania. They have irrigation channels galore because of the runoff from Kilimanjaro on the doorstep, but it's all contaminated with pesticides and parasites, so they can't drink it. Water is sourced instead from the local river and not boiled. But it's just the tip of the iceberg. In India, bicycle-borne health workers need clean water for washing skin. Again, I apologize for the picture, but this is the reality. 20 million Indians have lymphatic filariasis, where it's the same condition as I showed you in Africa with podoconiosis, but this is caused by blockage of the lymphatics by filarial worms transmitted by mosquitoes. But the reality is that this is the same patient. In a year, you can take them from this to this by washing the skin, by using emollients. This clinic uses yoga as well to get lymphatics working and get them moving around. Simple, low-cost intervention. But again, supply of clean water is an issue. And so I find myself in a unique situation where my company has a technology called Pure, and it's a little sachet. And in the question and answer session, we're going to do a little demonstration. It's old technology. Been around for centuries. Alum salts, stir them into dirty water, neutralizes the charge on particulate matter, it all flocks together and sinks to the bottom. That takes days to happen. This all takes place in 10 minutes, and I will do a demonstration later. We have a thing called the Children's Safe Drinking Water Campaign, where we have so far donated 1.4 billion litres of clean water on a not-for-profit basis, and there's me with my silly hat demonstrating it to villagers. And so we're seeing what we can do to provide clean water where it's needed in sachet form for podoconiosis carers and also lymphatic filariasis carers. I want to spend the last minute and leave you with, I think, inspiration. This is just the most wonderful thing that's happening in the uplands of Ethiopia. The Mossy Foot Project, if you Google Mossy Foot UK, these are former sufferers who are now cured, although the reality is that they will never be cured because they have to maintain skincare, otherwise it will come back. These are now making shoes for the sufferers because you need to prevent the foot coming into contact with the soil. Ethiopia is not short of leather, and so they're stitching together leather here for the feet that obviously don't fit normal shoes because they're so big and angular. They're using car tires for the soles. They produce 400 pairs a month, but they need 800. They serve only 39,000 of the 1.9 million people that are in need of help. They pile them on the top of 4x4s. They take them out to the villages and the clinics. And here we have a clinic here where hundreds of people arrive every week in all different stages of the disease and different attitudes and states of mind. But here's the hope. This is outside the clinic, and these ladies are now returning because they consider that they are sufficiently cured to come and get money from this lady here. She delivers microfinance up to $100 worth, and it gives these former sufferers the chance to make a new life for themselves. So here she is giving this lady her first tranche of money, and these ladies here, they've gone through the program. Now look at the difference. Yeah, people before, their head was down, they were embarrassed. These are proud ladies in all their finery. They've got their feet out for inspection, and these four ladies here, they have a little consortium going, dealing in oxen. This lady here, she makes butter and she sells it. And in village terms, they are now rich ladies, and they've turned their lives around. Nobody wanted them, and yet now they have a life for themselves. And here are their feet. You can see the scars, but the disease is now under control. Isn't that just wonderful? I'm going to end on a rather angry note to come back to my previous statement about the mismatch between need and funding. The reality is, and this is from a survey commissioned by the Gates Foundation in 2007 called GFinder, and it's an overview of R&D funding, about $2.7 billion worth, and where it goes. the truth is that it mostly goes to the big three: HIV/AIDS, malaria, tuberculosis. Less than 6% goes to the diseases that actually kill most people: pneumonia and diarrheal illness. And guess what? Virtually nothing goes to skin disease. And that is not right. 60% of funding came from just two entities: the US National Institutes of Health and the Gates Foundation. Now, I'm happy to say that the EC came third. But again, this is not right, is it? So let me finish on this and remind you, skin is the ultimate membrane. It is prominently displayed. It speaks before you open your mouth, and we are starting to take our first steps in understanding its pivotal role in signaling age, health, and attractiveness. But it's an entropy regulator. It's our first line of defense, and basic skincare enhances life in the developed world, but it can save lives and livelihoods in the developing world. I think I know which ladies I prefer, actually. I love these ones. I fell in love with them last year. On that note, I'll end my lecture. Thank you.
Well, thank you, Paul. Very interesting lecture there. I'm sure there are quite a few questions. If I could ask, if you do have a question for Paul relating to the presentation, would you please put your hand up? And then if one of the mics comes to you, if you would mind standing up, just giving us your name, and if necessary, if possible, could you give us the institution or where you're from, and then ask the question. Thank you. Do we have any questions? Gentleman at the back.
I'm Doris Schmetterling, and I'm a member of the Royal Society of Chemistry, and I live in London. Actually, I've got three very short points. One is the correlation between the carbon dioxide emissions and the death rates. I couldn't quite see. I didn't see a correlation, but is there a place where I can look at that again?
Yes. If
you all three, then you
can. We can exchange emails, and I can send you that.
If UV is harmful, how do we balance covering our skin and the need to have a bit of UV to get vitamin D? And the third point is that of the examples you showed, almost all of them were female. Why is that?
Okay, these are good questions. Matthew and I, we talked before this lecture, and we thought we know we're going to get a question about vitamin D. And obviously this has made headlines in the last few years, and the fact is that we have this dilemma. The fact that vitamin D is made, was synthesized in the body through interaction of the ultraviolet light with skin, and the fact that ultraviolet light also it drives a lot of the damage endpoints that we just talked about. So I'll start the ball rolling by saying, first of all, that actually you start the ball rolling with your point about how much UV we actually need.
Well, as was said at the beginning, I work quite closely with, or the British Skin Foundation works very closely with the British Association of Dermatologists, and they've obviously been leading concerning this particular issue, and working closely with people like Cancer Research UK as well. It's a big debate happening just before Christmas, and it will continue to go throughout 2011, I'm sure. But basically, the rule of thumb is that skin is different for all of us. There are, what colour we are, what gender we are, our age. And so the rule of thumb that we are, or the British Association of Dermatologists are looking to take, is that during the summer months in the UK, just going about your everyday business, whether you work in an office, a housewife, work at home, just going about your everyday business, you will get enough vitamin D through sunlight. We are stressing that we don't want people to obviously start thinking, right, this is the green light to sunbathe, to be reckless out, especially in the hottest months of the year. That's about the UK. I don't know if you want to mention, from a global perspective. or add anything?
Well, in terms of the use of sunscreens, I think people often think sunscreens are completely block UV photons, and of course they don't. They just reduce the flux of photons through the product layer. And so even with SPF 10, 15, there are UV photons reaching the skin, and there is vitamin D synthesis going on. Secondly, people don't apply sunscreens at the right concentration. The SPF test is done at 2 milligrams per centimeter squared, and there's a lot of data showing that people simply don't apply it often at that concentration. So I think, even with the use of sunscreens, we'd argue that there are still UV reaching the skin. I think as well we have to remember that if we're thinking about humans as whole beings, then we have to remember that there's a source of vitamin D from the diet as well. And I think in terms of looking after whole human beings, we have to remember that we have to be promoting good diets across the globe as well.
Exactly. It's really, it's a whole picture, as Paul mentions. If we can promote the whole kind of, the skin is part of the body, and what you put in your body, what you put on your body is just as important. And as far as the vitamin D debate is concerned, we're hoping that, as I say, people will understand that it's not the green light to go out and be reckless in the sun, but also, as Paul mentioned, it's about diet as well.
Can I just say, my point is that after this lecture, I will go out, cover myself with sunscreen, and cover myself with clothes, but that's wrong too. That's what I want.
I think clearly we need to be sensible and manage sun exposure, not obliterate sun exposure. There's plenty good about the sun. Psychologically, it provides warmth, it produces vitamin D. I am not for a minute saying that we cover ourselves completely. I love the sun personally. I'm saying that we be sensible and go to any of the websites like BAD, BSF, and you'll find sensible advice that doesn't say become a hermit. It just says have sensible management of sun exposure. I think there was a last question you asked about there's only women, and I'm not quite sure whether you refer to in the slides here or in the clinic that I showed, or all of it. Yeah, there has to be a focus for a given talk, and I focused on female skin tonight. It won't surprise you to know that in terms of the psychology work, we are moving into male skin. I think it will be fascinating to see whether the same patterns emerge. Will wrinkles still code for age, or will we have measures of wisdom and experience coming out? So I think it'll be very interesting. But we are starting to focus on men. In terms of the clinic, clearly you saw that there were plenty of men in the clinic as well. I just chose to focus on a bench with ladies because I just thought their story is wonderful.
Lady at the front here, please. There's a lady in the second row. Can we get a microphone?
Well, Eileen Morrison. In the past, I understand that skin cancer was quite rare, even at times where it was normal to leave babies outside in the sun all day in their prams. Agricultural workers, fishermen, and such like worked out of doors all the time in the hot sun, and yet they didn't seem to get skin cancer. I was wondering whether there's anything in the idea that exposure to the sun from birth practically somehow toughened it or caused changes which meant that they weren't affected when they were older.
Well, I'll just start the ball rolling by saying I think this is more to do with reporting rate than anything else. Matthew, do you want to take that?
Well, really, skin cancer and all skin diseases is about reporting rate. If we look back historically, in previous times in the old days, people were less inclined to actually report any problems with their skin, any particular disease or so forth. And the same with skin cancer. Usually it was too late is the answer. A lot of people, by the time they would see their doctor, it would be too late to even do anything about that. And also the fact that the statistics and the numbers are kept in a very different way nowadays to how they would have been kept a few years back. But the interesting thing about skin cancer as well, the growing numbers, and of course we're all worried about it, and we looked at what happened with Australia during the 60s and 70s. The rate is growing year on year, 100,000 cases, as I said, last year, which is just shocking in the UK. And as you mentioned in your talk, you know, globally, who knows kind of thing. I think it's about the fact that in the UK, a lot of people are now coming forward, especially the older generation, who realise that perhaps during the 70s and the 80s, they perhaps were out in the sun. You know, we've all heard the horror stories about people putting on vegetable oil or just oil, baby oil, onto their skin when they went on their 2-week holiday to Spain or to, you know, hotter climes. That's the damage, and we're now seeing that damage, because skin cancer, it takes a long time. You know, you're talking at least a decade, even longer, for a lot of cases to actually manifest themselves. So it's a kind of a collection of different factors. The gentleman at the back there.
John Farmer, no affiliation except perhaps as a somewhat sceptical Unilever shareholder. To what extent do moisturizers and associated cosmetic oils and unguents marketed by extensive advertising actually do any proportionate good? It's been said that such marketing is essentially selling hope. To what extent is there a demonstrable benefit in exchange for the outlay on such substances, especially as in your talk you've suggested that particularly in developing countries, washing and basic protection actually has dramatic results. To what extent are we in the developing world deluding ourselves that these heavily marketed products are actually doing substantive good?
Well, trust me, I'm 23 years in the business. I'd have trouble sleeping at night if I didn't honestly believe that the products which I've had a hand in developing do something. I think that they can have profound effects. And so if you take, for example, simple winter xerosis or simple winter dry skin, you can switch on enzymes that are now dysfunctional in the outer layers of the stratum corneum simply by providing water to them, which they need as functional proteins. They will then go to work and they will remove the debris at the surface, and then there's a cascade of events as chemical messages are sent into the deeper layers of the skin, and you'll end up with soft, smooth, supple skin before you had dry, flaky skin with background chronic inflammation. So just raising the water content, literally in the outer microns of the stratum corneum, can have profound consequences for skin. The fact is that most of us live our lives with some low-grade level of inflammatory process in our skin, particularly on areas that are exposed to the environment. So again, this is work we're doing with the School of Pharmacy. If you look at the quality of corneocytes in the stratum corneum on the face versus covered parts of the body, they are smaller, they're less mature, they're less hydrophobic, they are less rigid, and all of these things are needed for healthy stratum corneum. And what we believe is happening is that it is the daily exposure to sun, to surfactant, to repeated washing that causes this change in the corneocytes of exposed skin. We've shown that with 2 or 3 weeks of, again, simple moisturization, that as you elevate and keep elevated water levels in the outer microns of the stratum corneum, you can reverse that. And so I argue strongly you can have profound effects. It's just relative. So once again, in the West, I have basically fairly good condition skin. Even winter xerosis is not a particularly health or life-threatening issue. In the third world, because there is a much higher microbial load, much higher dirt load, I don't have access to basic health care, medical care, or clean water. What in the West is a simple cut, or abrasion, or scratch, or burn in the developing world can turn into something much more serious, much more quickly. But I maintain that the effects are no less dramatic in the West than they are in the developing world. I'm a passionate believer in simple hydration. And that, of course, is point of entry. On top of that, we've learned to do lots of other tricks as well. Genuine technology. Very interesting technology.
Do we have a question over? We'd like to, gentleman here.
Jeff Bull happened to be a member of one of the other courtyard societies, but it's nothing to do with this, and a former active runner. You might or might not know that within the running community there is a very small-scale initiative to do with mossy foot disease.
Oh.
English runners sending
Shoes.
unused shoes
Yes.
out to Ethiopia.
Yes.
One particular person in Ethiopia, former British marathon runner, Richard Nuraker, I think he does some coaching out there. I think he is the recipient of it. But one club I belong to sort of advertises this and encourages members to provide shoes, and a number have been taken out. I don't know if it extends to any other athletic clubs than the one I'm concerned with. That's just a point of information. Secondly, on the athletic scene, it has puzzled me for some years as to why there is this apparent vote, I don't know if there's any rationale behind it, for particularly women athletes to wear the skimpiest of fabric when they're running. Even in marathons, when they're exposed to the sun for a long time. It is less apparent with African and Asian runners, whereas men don't do that. They wear singlets and so on. Even in sprint terms, they wear almost full body gear, but women don't. So I don't know whether you have any rationale yourself to explain that.
I must admit I
Third
don't.
Is a question. At what point is it reckoned in human evolution did the balance change from being hairy enough to counteract the effects of too much sun and being too little hair, as it were? It seems to be a crucial variable in that, as far as I can see.
Well, that's a fascinating question. I have no answer whatsoever to the question about women's attire as they perform sports. But I just, as a comment, there is increasing amount of research going into clothing which can reduce the flux of UV photons through that material. And so, for example, increasing the thread count in textiles, increasing the or decreasing the porosity of materials can have a dramatic effect on transmission of UV photons through these materials. So we're seeing the start of clothing being marketed, for example, for children, very thin, tight-fitting beach suits and all the rest of it. So that I think the same applies to sports material as well. And as the question about evolution, that's a great question. I have no idea, sir.
Could I just add a point that, as Paul's just mentioned, regarding clothing, and especially clothing for children when they're on the beach? I'm pleased to announce that quite a few of the big retailers now in this country, people like Marks and Spencer's, Next, are actually putting money into just normal clothing, which has got this UV protection in it as well, as part of the fight and the education against taking care of yourself in the sun.
Does it help the skin to stay cool? Does it keep moisture in there? Stop overheating the
it works in combination with the body's normal system for keeping cool. So we're talking a lot of these clothing, things like T-shirts, for instance, not necessarily these kind of the children's wetsuits, which you may have seen that a lot of children like wearing on the beach, and the Legionnaires hats. These are just normal T-shirts, shorts, long trousers, which are usually cotton, but they've not just the weave, but also there are some washes that are now coming in that will provide that UV protection. But they're making it very clear that this is to be used in combination with other UV protection, so sunscreens, for instance, on the naked areas of the body, the hands, the face. Lady down here in the second row.
Hello, I'm a medical anthropologist, and I have a question about if you care to comment on some diseases which seem to get better in sunlight, for example, psoriasis. What's going on in that sort of dysfunction? Thank you.
Okay, well, I'll take it first of all. Really what's happening there is you're making use of the fact that the skin responds to sunlight, obviously by producing more melanin, because melanin is a very broad absorption spectrum, and so it preferentially absorbs short wavelengths, but also the fact that you get hyperkeratosis, so the skin makes a thicker stratum corneum. With a thicker stratum corneum comes a longer path length, a better barrier, and so the skin tends to become a better sieve, a better interface for reducing the flux of irritants, other materials through that layer that encourages the inflammatory process. And so that's why for some conditions there's UV treatment, obviously carefully managed, to carefully increase stratum corneum thickness, to increase path length, and to make it a better barrier.
Well, as you mentioned in the question, psoriasis is a good case in point. But this is part of the conundrum that not just the British Skin Foundation's face, but also dermatologists in this country and around the world, that yes, there are conditions that do seem to get better in sunlight, but it's about managing that and making sure that, obviously, again, like the question at the beginning, that you don't suddenly just think, oh, I've got psoriasis, I can go mad in the sun and what have you, because ultimately you're going to cause yourself more damage in the long run. An interesting point was it was used as an argument by the sunbed industry a couple of years ago regarding the fact that certain skin diseases were obviously helped by UV rays, but the argument was short-lived, and it's just a case of making sure that, you know, obviously you're sensible if you do happen to suffer from one of these conditions, or if indeed you do need light therapy, as Paul's just mentioned, that's actually done by a reputable physician rather than some backstreet organisation.
Does that tell you anything about the nature of psoriasis that would assist in finding a cure?
Well, as far as research is concerned, which is obviously what the British Skin Foundation has been funding, off the top of my head, I am not aware of any work that we're currently funding down that particular line, but it wouldn't surprise me if there is something happening internationally. And if we were approached with a particular application for that study, then I'm sure our dermatologists would look at it quite favourably. But again, it's about control and making sure it's done by the right people in the right environment.
I think it just underlines what we already know about psoriasis. It's a hyperkeratotic inflammatory process, and you have to slow it all down. You have to reduce the rate at which skin is turning over, and reducing the ability of skin to allow exogenous irritants in is a key part of that. And so, like I said, really, in the use of UV, you're making use of a damage reaction process to ultraviolet light. It's a protection mechanism, but it has to be managed. And I think that's what Matthew was saying, is that you can't just rush out and expose your body to unknown amounts of ultraviolet light.
Thank you. Any lady in the orange? I think it's one.
Jennifer Goldsmith. I'm just a private citizen, but a RSC member. Can you explain why clean, supple, dry skin would irritate?
You go for it.
Why clean?
No, non-cracked. Non-cracked. It's in good condition, but dry skin would irritate.
Okay. The word irritate is a very subjective word. So, so this is well known. If you ask any population across the world, do you have sensitive or irritated skin? It's very large numbers will respond yes. If you try and find a mechanism by which they are apparently being irritated, often you cannot find anything at all. So what do you conclude? Is it some kind of strange kinesthetic thing that that's going on, or is there genuinely some kind of real biochemistry or physiology? And the true answer is, in many cases, we just don't know. Certainly, when you have dry skin, again, small changes in stratum corneum mechanics can have, again, a profound effect on the ability of skin to extend itself and to move easily. And so, again, that chart I showed it was called the elastic modulus, or the ability of skin to flow. Small changes in hydration, large changes in stiffness or in softness. There are little nerve fibers that extend up into the epidermis, called C-afferent fibers, very, very sensitive to these kinds of changes. And so small changes in stratum corneum mechanics, we can feel them. And so, I remember stepping off a plane in Russia. It was minus 25. The air was bone dry. Within 10 minutes, I could feel my skin tightening up. That's not me imagining it. That's literally this membrane that surrounds my body stiffening up and constricting my movement somewhat. And it feels prickly, and I think a lot of it is to do with, again, the profound mechanical changes in stratum corneum. But also the fact that compromised barrier, you're letting in materials that the body responds to as non-self, and a lot of those mechanisms will involve pro-inflammatory chemicals that again will tend to provide signals that we interpret as irritation. And that's just visible, like erythema, increased blood flow, as well as tactile and sensile. So I hope that goes some way to answering your question. But I think in many cases we just don't know. When somebody says my skin's irritated, we can't find any obvious thing that's happening.
I will only add that it's very similar to pain. It's very subjective. Pain to me is probably different to you, and how you actually measure that, it's very difficult, which is one of the reasons why dermatologists will be the first to admit that when they're looking at certain diseases, or even healthy skin, it's very difficult to actually identify a precise way to measure that and what the patient or the subject is feeling. So it's a difficult place. Also, it's very fair to say that dermatologists still know so little about the skin, isn't it? It's what we've seen here tonight is incredible stuff, and there's obviously reams and reams of research out there, but at the end of the day, we know a lot more about other organs inside the body than we actually do know about the skin that surrounds us. Yeah. Oh, yes, of course. Any further questions? We've got time for one more. Gentleman right in the middle, if we could. Thank you.
Paul Fielding. I'm a member of the Royal Society of Chemistry and also the Psychological Society. To what extent is there a correlation between variation in skin pigmentation in health? Or do we just perceive a correlation that's not really there?
You go for it. It's yours.
Well, even taking the the process I described tonight, which is the accumulation of lentigos, diffuse pigmentation as a result of exposure to ultraviolet light. We know that ultraviolet light depresses immune function, and in that sense, could it be that this is an ancient signal, an ancient visual signal, that this person is inherently more susceptible to disease than somebody else who's not had this exposure? Bear in mind also the fact that it takes years, I think you were talking about this earlier, years to build up not only neoplastic response in terms of cancer, but also these damage endpoints. And so damage I do to myself today may show up in 6, 7, 8, 9, 10, 15 years' time. And so it's a signal of previous damage, and the fact that you are probably older and, dare I say, less suitable as a host for my genes than somebody else. This is the way that evolutionary psychologists talk. So I think even in that scenario, yes, I think you could argue that there are plausible links between pigmentation differences and I'm talking again not about basal coloration, but about distribution of chromophores and overall systemic health. So if you want to comment on maybe
I think you've...
what about disease states where you have holistic disease states, well, systemic disease states where you have
Well, it's interesting because obviously a disease like vitiligo, for instance, it's more of a case of I've spoken a lot tonight, or mentioned the fact about the British Skin Foundation supporting, it sounds like research, lab-based work and what have you. But we haven't really, you touched upon it slightly, but the psychological effect of skin disease, or of healthy skin. But as far as I'm concerned, it's the psychological effect of skin disease itself. And with something like vitiligo, it can be very damaging, not because it's not physically painful, but for a lot of cultures, it can be incredibly damaging, especially even a multicultural country like ourselves. Communities around the country, if there is a sufferer with vitiligo, it can cause real problems, rejection, not just among friends but also family. So I think it's a very complex issue, and it's something that we certainly want to look at or would be interested in researching further. But that's all I can really say about the disease side of it. But I think, hopefully Paul's covered the healthy skin side of it for you.
Just one more quick comment. I think if you look at the last maybe 10 years worth of peer-reviewed literature, something that's emerging now is the connection between state of mind and skin condition. So we know that substances like substance P, circulating cortisol, these stress markers in plasma have a profound effect on barrier function. And so, the old adage, it's my wedding day and my skin's falling off, turn out to be, there's actually a lot of good science behind that. So there's been some very interesting studies done. So, for example, taking midterm students versus students in exam conditions, couples going through divorce versus couples that are happily married. If you look at markers of barrier function in their skin, they are significant differences. In other words, people that are going through stressful situations tend to have weaker barriers that are inherently more susceptible to irritants, to surfactants in cleansers, all the rest of it. So I think that's something else that's emerging. So clearly, irritated skin, spots, these are blemishes, visible markers that, again, we up here, you start making decisions about health particularly.
Thank you. Thank you. Thank you very much. Interesting questions, interesting presentation. We'll be available to chat further over coffee and tea, which I understand is going to be available shortly where you came in. But for the time being, thank you very much. Thank you.
We've been circling each other. Nice to meet you. Well, I missed the first part.